Hit it.
Yeah.
Okay, hello, I'm Tim.
And I'm James.
And this is QuasiCast. So, today we're discussing how we can save the world by coating buildings in rotten cabbage.
Yep.
Sounds perfectly sensible to me.
Plausible.
No, but very plausible. This is a real product, as crazy as it sounds. This is AuReus, which is the recipient of one of this year's Dyson Awards. So the Dyson Award is nominally a prize that's given every year to young innovators who create world-changing inventions, I suppose is the tagline that they would use.
Yes.
And this particular one stuck out to us. It was quite widely reported in the British press a couple of weeks ago. So I think best place to start is just to summarize as best we can what this is supposed to be.
Sure. Would you like me to have a go at the one-line elevator pitch?
Yeah, you can try the elevator pitch.
Yeah,
so
well, I'll
piece it together.
I'll use the elevator pitch right from the inventor's mouth.
Right, okay.
Which is that AuReus is actually a material or technology that allows other devices to harvest ultraviolet light and convert it into electricity. AuReus is based on a plastic material, so it can be formed into different shapes. So essentially, he's claiming to have created a product which can allow us to harvest light which was previously unharvestable, the ultraviolet light, and convert it into visible light, which can then be harvested and converted into electrical energy using standard photovoltaic cells or solar energy cells, as they're known.
Yeah, and I suppose one of the bits that's missing from that, which was a key part of how it was reported in the British press, is that this plastic material is supposed to be made from byproducts from rotting vegetables.
That is correct.
And introducing that kind of starts us on one of the issues that we both kind of had with this product when we were reading about it, is that there's a lot of different justifications for why this product is green tech, I suppose. So yeah, there's this idea. Obviously, one of the main sources of renewable energy is through photovoltaics. It's probably, I don't know, James. What would you say? Do you think photovoltaics is one of the more promising green technologies alongside for energy generation, alongside things like wind power?
Yes, well, I mean, I'm no expert, but based on my, watching various new media coverage over the last 2 decades of photovoltaic cells, the efficiency has been increasing in leaps and bounds, and I think calculations show that typically, seemingly they always give it in units of US states, but it's you could cover like one US state in solar cells and power the entire of the world's energy needs, and it's one of those things that I feel like the technology is there. It's very much a case of political will at this point.
Yeah, absolutely, and I mean we talk about that a lot, and I remember giving a presentation a couple of months ago about technological innovations that really can save the world, and just saying it like that probably tells you everything you need to know about what I think about this. But yeah, that was one of the things I used in that talk, was saying that you only need to cover 1/3 of Texas in solar panels and you could power the entire world. And of course that sounds like a lot, but 1/3 of Texas is less than 1% of global agricultural land, so it's really not that much. No. But one of the big problems in boosting the efficiency of solar panels is making sure that they're as broadband as possible. So
can you explain what broadband means?
Yeah, sure. So all really solar panels work in some way by using a dye, basically. So dyes have color because they have a band gap, a difference in energy between different states. And when light interacts with that dye, it causes some excitation. Now, in a dye, you have that excitation and then it relaxes and that process gives it color. That's a really bad explanation, but I'm not here to, we're not talking about dye. But when that's in a solar panel, you can take that excitation and you can pull those charges that are created in that excitation process apart. And that gives you usable current. But those dyes are only going to be sensitive to specific parts of the electromagnetic spectrum. So if you want to create a really good solar panel, you need to engineer materials that absorb light over a very broad range. So in terms of color, they need to absorb blue light as efficiently as they absorb red light. Now, people have gotten very good at making these broadband photovoltaic cells. It's like you said, really been advancing very fast, but there are regions of the EM spectrum outside what we can see visibly that include infrared and ultraviolet, which is the focus of this. And ultraviolet light is much higher energy than the light that we can see, and it's generally missed by solar panels. It's not absorbed, and so you don't get any energy from it. Now, what this invention is proposing to do is that they're supposed to be creating this plastic panel, and then light shines on the plastic panel and interacts with this dye, and it fluoresces. So it takes that UV light and absorbs it, and then re-emits light at a different wavelength, so that it's in the optical band, the visible light. And you can then supposedly harvest that with a conventional photovoltaic.
I would sorry.
Yeah. Go for it.
I would say this raises, I would argue, one of the core concerns that any reviewer would have of this piece of technology, which is that the core process by which light is, as they put it in the James Dyson Award summary, although incorrectly downgraded from ultraviolet light to visible spectrum light, that process, as with most processes in physical reality, has an efficiency, and we don't really know, based on the available information, what the efficiency of that process is in this case. And if the efficiency is not very large, only a small proportion of the ultraviolet light is converted into visible light, then of course the product isn't going to be very effective.
Exactly. Yeah. Now, I've actually published papers on the topic of photovoltaics before, and the one thing that I learnt from that experience is if you go to serious scientists and engineers working in this field, and you try to publish some new material or some new mechanism for a photovoltaic, and you don't very clearly lay down exactly what the efficiency of your material is, and a whole load of other information like the zero current bias that you get, the maximum fluence. There's a whole catalogue basically of critical information that people who really work in this field need. And if you don't give them all of that information, they will take you to the flipping cleaners. They have, it's, and there's a very good reason for that, because this field, it's critical. Creating renewable energy, creating a really good photovoltaic, something that really revolutionizes the field, would be economic dynamite. You could completely revolutionize the energy sector. And because there's so much money in it, it's really attractive to charlatans. I'm not saying this person is a total charlatan. We've been warned about not accusing people of fraud, and I'm trying to remember not to do that. But if you try to say that you've created this amazing material that's going to revolutionize photovoltaics, and you don't even give basic information about its efficiency, you may as well just be saying anything. You may as well be saying that, Wellington boots are going to revolutionize the energy sector for all the good it does.
Yes. I think that just generally the lack of quantitative information that is provided, certainly by the James Dyson Award summary, but of course the James Dyson Award summary is not a scientific journal, but I mean, based on the searches that I've done, it's very difficult, if indeed at all possible, to find quantitative information about this product, not just the efficiency, but indeed structural information. I mean, they make sort of statements seeming to indicate that there is some kind of pane of glass, and perhaps this material is infused into the glass, and that the light would sort of shine upon it, the ultraviolet light, and this material which is infused into the glass, this fluorescent material which is extracted from vegetables, would absorb the ultraviolet light and then re-emit it. And then they claim that the process of total internal reflection, which is a standard property of optical materials, would guide the light along the pane of glass to the photovoltaic cells, which would lie around the perimeter of the device. Now, this immediately, it rings alarm bells in my head. Because, we can't go into the details of how total internal reflection works, but just the very nature of incident radiation followed by re-emission is that the re-emitted light is diffuse. It is not coherent or ordered, and therefore any total internal reflection is only going to capture, some relatively small proportion of the light which is being fluoresced, which is another source of inefficiency on top of any inefficiency that occurs during the process of absorption and re-emission. So there are many questions that are raised just based on the fundamental description of how it's going to be constructed.
Yeah, and there's a sort of more structural issue that's bound up in that, because one of the problems I have with this whole concept is that when people talk about maximizing the amount of energy that you get from photovoltaics, one of the key things that they talk about is the solar fluence, right? So the amount of light that is hitting your solar panel, which, obviously is the fundamental limit for how much energy you're going to get out of it. The energy will be a fraction that's determined by the efficiency of that total amount of energy that's hitting the panel itself.
Yes.
Now, under normal circumstances, you have a 2D array of solar panels that covers an area, and you're doing that because you're trying to maximize the amount of light that you can get. Fundamentally, this system is taking that 2D array and it's reducing it to 1D. Now, of course, the idea here is that the panel itself is going to somehow focus that light so that the whole window is collecting all of that light and funneling it towards the edges via this total internal reflection. But as you're saying, that process has some finite efficiency. There's always loss from a total internally reflecting system. If you take an optical fiber, unless an optical fiber is something that's perfectly designed to support total internal reflection from a wide range of angles, but that still has some finite loss.
Yes.
And so if you take this big window, you're going to be losing energy, and then you're trying to funnel all of that energy onto a 1D strip of photovoltaic. So just in terms of scaling efficiency, you already have this massive loss just from the setup. And that also speaks to something really critical, because one of the things that's often a red flag in these sort of slightly fuzzy inventions that come through things like the James Dyson Award is that they have this one central product that they say is going to do all these amazing things. But then there's always that point where they say, and we'll use this technology to make it work. And it's just kind of, spackle, over the cracks in the logic. And in this case, that spackle is the actual photovoltaic, because that's what's really creating the power. The window itself, this glass or plastic that's impregnated with this dye, is not generating any power itself. All it's doing is acting to absorb UV radiation and fluoresce. That's all it's doing.
Yes, and I guess just to reiterate what you said, with photovoltaics, the equation for how much energy they produce is the elements of it are surface area of the photovoltaic cell and the amount of radiation per square meter that's hitting the cell, and the intensity of
Yes.
that radiation. And in this particular instance, the surface area of the photovoltaic cell is artificially small.
Yeah.
The intensity of the radiation is going to be low due to the inefficiencies of the conversion process and the geometry by which the converted light is funneled to it. And the intensity is going to be low just by virtue of the by virtue of the fact that the light is being constantly absorbed and re-emitted as it goes from the sun, from the external world through the device, and then eventually to the photovoltaic cell. So it's losing almost at every fence that it's going to have to jump. And
that is the opposite of what you want in a photovoltaic system. You want to minimize all the loss points, but there's actually something even more critical than that, because even if the total internal reflection idea worked perfectly, and you had this really intense light that was shining on this one D array of solar panels, the efficiency of solar panels does not scale linearly with intensity.
No.
And you can see this if you take a solar panel and you expose it to sunlight, and then it will work at whatever it's rated to, 20% efficiency or whatever, if it's a really good one. If you take a super bright xenon laser and you fire that at the solar panel, it won't show you the same efficiency, because the thing is that if you create very high if you have lots of excitations in one of these panels, you start to hit limits where you get these non-linear effects. And this is getting rather too technical, but it's important because it's a critical flaw in this whole design. Because the idea is that you can just take all of this light and concentrate it down onto this tiny little photovoltaic, and the efficiency will just scale perfectly. And it won't.
No.
It won't scale. So that you can't take a 2D solar panel array and just condense it like this. It fundamentally doesn't work.
I guess at this point, I'd like to draw attention to one of the things that struck me, one of the more major things that struck me when I was reading the summary in the James Dyson Award statement, which is that in the section labelled R&D, they said that additional research will be done on extracting the needed luminescent particles to allow a 100% from the current 80% sourcing of dyes from fruits and vegetables instead of chemical ones. Now, this statement implies that currently 20% of the luminescent material inside the device are in fact derived from non-natural sources, which immediately, if this was an academic paper, I would say, well, how have you determined that any effect that you're measuring is not due to these artificial ones rather than these natural sources?
It's rather like sort of coming out and saying, oh, we've invented, a homeopathic painkiller that works just as well as, the best ones on the market, and only 20% of our homeopathic painkiller is opium.
Yes, that's quite an apt comparison. And I guess another aspect of this, I feel this is more, because I feel I should say that we've obviously derived a significant proportion of what we've talked about from the statement in the James Dyson Award, but, in addition to some extra interviews that we read with the inventor. But so, the language that the James Dyson Award is stated in may well have been re-edited by somebody who's employed by James Dyson. I'm not exactly sure how these things are. So it may not be the language that the inventor himself used. But there is a lot of use of terms and comparisons to other physical processes that are completely unrelated. For the purposes of dressing up what is fundamentally quite a flawed idea, potentially.
Zhuzhing this.
That's right. I think that is the technical term. But it's. I think points. Perhaps it's because of the fact that the James Dyson Award is fundamentally a business award. It's not a technology award, in that it is not awarding somebody with, due to the fact that they have demonstrated that they've made some particular scientific discovery. It's an exercise in business, which is at the end of the day an exercise in marketing.
Exactly. Absolutely. And to me, the worst example of this is the thing that gives it its bloody name, because it's called AuReus, because it's supposed... Let me read this out, because this is from the How It Works section of the James Dyson Award. Both AuReus devices, Borealis, solar window, and Australis, which should be Australis, so, just Google it, for God's sake. The southern lights are called the Aurora Australis, not Astralis. Sorry, I know that that's being pedantic, but it just really hacks me off. Australis solar wall uses the same technology derived from the phenomena that governs the beautiful northern and southern lights. No, it doesn't. That is not how the northern and southern lights work. And the fact that they don't understand that is a massive red flag, because when you have a glass that's luminescent, what's happening is it's absorbing radiation, optical, but in this case, but UV. There's a dye that's absorbing that, and then it's re-emitting that light so it creates an excitation, that excitation relaxes, and then it re-emits that light. What's happening in the Aurora Borealis and the Aurora Australis is that very high energy particles from the solar wind are colliding with gases in the upper atmosphere and ionizing them. This is not an ionization process. And I know that seems like a pedantic point, but it's actually really bloody important, because it shows that at least the person who wrote this summary fundamentally doesn't understand how solar panels work.
Yes, which when the core element of their design is solar panels, does, inspire doubt.
Yeah. For sure. And I mean, the rest of this James Dyson summary continues to be really quite confusing. There's a lot of, as we said, kind of a lot of different... Well, like you said, James, it's an exercise in marketing, and it's just kind of piling on these different ideas and justifications. One of the things that keeps getting mixed in is this idea that buildings are somehow, endangering everybody's health by reflecting UV light onto them. And
yes,
that this absorbs UV light, so it's not doing that. And yes, okay, it's absorbing some UV light, but unless they're claiming that it's 100% effective, it's not going to work. And actually, one of the things that he says, I think in an interview he gave to The Guardian, I think, he says that... most buildings, like high-rise office buildings, they have this coating on the outside of the windows that reflects UV, which many do. And he says this is a problem because it's reflecting UV light onto people in the street. But the reason those buildings have that UV filter is so that if you're working in a high-rise office building that's got, floor-to-ceiling windows, you're not constantly being sunburnt by the UV that's coming through the window. So if you take that coating off and you replace it with this thing, and it's not 100% efficient at absorbing UV, all you're doing is endangering the people in the building.
Yes, which is not an outcome that anybody wants.
So it's just fundamentally badly thought out. And so I feel like maybe it might be a good time to kind of put this in the wider context of research in this area, perhaps.
Sure.
Because this isn't something that just came out of the blue, this idea of using these fluorescent windows. This is actually something that's been around for a long time. And it's explicitly referenced in the James Dyson Award information that one of the bases for this, they don't call it an inspiration, which is an important distinction, because, they're not acknowledging that the people who worked on preceding technologies had any influence on their idea, which is a bit, bad faith. But one of the key foundations for this is something called a quantum dot solar window. And this was developed by a team working in Los Alamos. It was published in Nature Photonics in 2014. And on the face of it, this is a very similar technology. So you have a glass that a specific type of glass called PMMA, and it's been embedded with quantum dots, cadmium selenide and cadmium sulfide. And those quantum dots, which are just like very small spheres of metal, basically, is that fair?
Yeah, that's a pretty good summary.
Yeah, I mean, I don't want to start trying to describe what quantum dots are because we'll be here for hours. But they absorb light and then they re-emit it at a different wavelength. So similar to what's being described here. But the critical thing about this quantum dot solar window idea is that the glass that's been impregnated with these quantum dots acts as a waveguide. So what you said before about how when a material fluoresces, it's diffuse, it emits that light equally in all directions. That's not the case here.
No.
Because the array of quantum dots is designed very much in the same way that you design a quantum dot laser, the same kind of glasses that are used in very high powered lasers, where the resonance in your array of quantum dots has a direction.
Yes, I think it's what is commonly referred to as a metamaterial.
Indeed, exactly. And it's so interesting because you read the summary of this in the James Dyson Award, and the tone of it is very much critical of the work done by Los Alamos, where they're basically saying, there's a thing here saying, how is it different versus quantum dot solar windows? And they say, AuReus used cheaper materials, and as of 2019, has been applied and tested for mech and acoustic. Do we really have to abbreviate mechanical? I mean, it's already bad enough we're abbreviating things to tech, but mech? Fine. Anyway, tested for mech and acoustic properties for building settings. In terms of application, AuReus has been constantly leading over quantum dot solar windows. So the criticism is very much this team in Los Alamos, spent ages researching this material. It's really expensive, and look, we've got this guy, this young inventor who's got some moldy carrots and managed to do the same thing, only better. And it just shows a total lack of respect for the actual experienced scientists who've devoted their lives to studying this field.
Yes, I think that's true. Although I would say that, in the minds of the James Dyson Award people, they're sacrifices on the altar of marketing, as we've said, and it's it speaks to business culture more than perhaps any personal enmity that these people have, or just indeed, it's a blasé attitude towards the efforts of the scientific community as a whole, and an effort to further crystallize this idea of the genius individual inventor working counter to and indeed independent from the rest of the scientific community, despite the fact that that's not the case.
The rebel disruptive tech innovator, which is the sort of classic archetype, and the James Dyson Award really kind of captures that, because all of the recipients of it, they're always people who are, people who've often not even started their careers at all, people who are still in their undergraduate degrees, and they've invented something that's going to completely disrupt the field, that's better than they're only 20-something and they've already outperformed all of their professors. That's the kind of the story that is being sold here. I think it's important to say that neither James nor myself dislike or have anything against young innovators or young scientists.
No, that's correct. It's more a concern that these sorts of awards have a high profile, largely because we live in a society where large business is known and has a high profile, and therefore the way that these businesses represent scientific research has a significant effect on the way that the public interacts and understands science, and that's important.
That is really important. I mean, how many people do you think have actually who are outside of the field will have read that 2014 Nature Photonics paper versus have read the numerous articles that have been published about this?
And I mean, ultimately, that's right. I mean, they can't be expected to read the paper.
No,
and
okay.
therefore that's why it's all the more important that people like the individuals involved with organising the James Dyson Award make the effort to vet and present such work in the proper context and with the proper caveats.
Yeah, indeed. And it's also just so important that it's great that you have these really young scientists or engineers who want to come up with these big ideas, but what they desperately need at this stage is good guidance. Like the reason the reason people go and compete to do PhDs with well-known professors or well-known academics is because they want their experience and their guidance. You know, it's expected when you have a new PhD student or, you know, a new postdoc who's at the beginning of their career that they will want to strike out on their own. They'll want to have their own ideas. But the reason people don't just say, oh, well, you know, you have a new idea, well, here's, you know, an EPSRC grant, go and make a business out of it, is because they recognize that it takes a collaboration between enthusiasm and experience to make a project actually work.
Yes, and also just in a more, I would say, fundamental sense, you know, technologies of the type which are going to have a significant impact in this day and age require teams of people. Even if it is, you know, to perform vetting and to review and to verify, you know, one man, one person, one individual simply can't do it. It's not possible.
Indeed. And I'm not going to say that this particular person is arrogant, because I don't know them. But the thing is that awards like this are encouraging them to be very arrogant, because everything about how the award is phrased and how it's awarded is saying you as the singular individual have revolutionized the field on your own, and you don't need anybody else. You don't need anybody else's input. But like you just said, the thing is that anyone can come up with an idea, but actually making sure that idea really works, that it is competitive, that you can make it into a product and that you can market it and sell it and that it will be valuable. You can't expect one person to have the expertise to do all of that.
No, and I mean, at the risk of moving into tangential territory, I think the source of this, what you just described, is from the tech industry, where you have people who are in the tech industry. It is possible, really, to up to a point, for one person to create at least the prototype for a product idea or technology themselves, to the point where obviously it needs scalability, and then you obviously need more people. Whereas, you know, when you're doing research or developing a product in a space which is operating in, you know, fundamental physics territory, or indeed fundamental any science territory, it's just a different ball game. Not because, you know, science is harder than tech, but just by virtue of the fact that, you know, you're dealing in what is essentially a continuous space in terms of, you know, what is true and what is not true. Whereas, you know, with technology, it's a far more, it's much clearer whether or not something is working or isn't.
I mean, I would slightly disagree with that. I mean, to clarify, like when you're talking about technology, you're talking about software programming, right? And the thing is that when you say fundamental physics is not harder than software and programming, I would say it is, but not maybe in the sense that the logic or the maths or the barrier to understanding is harder, because I don't think that's true. I think they're very similar. But the fact that if you're trying to do something like create a new type of photovoltaic, you don't just have to understand how it works and then, you know, write down a process. You also have to actually build the bloody thing, which is what you're saying. You know, and the real world, the physical world, often just doesn't cooperate. You can have a model on paper that you've very meticulously worked out, and it's taken you years to understand and uses the best expertise, and then you try to apply it to a real material, and the real material just doesn't work. That happens all the time. And this idea, like you say, that has been borrowed from the software tech industry, that someone can just kind of, sit in their bedroom and learn how to program, and they can make something amazing that will change the world. You fundamentally can't do that in material science, because making these materials, manufacturing them and testing them, requires very specialist equipment and knowledge that you just can't get in a bedroom lab.
No. So, I guess to wrap up finally, I was having a discussion with a friend of mine earlier this week talking about tech innovation, and he comes from the business sector. And he was saying that we were talking about the context of another product with, shall we say, spurious origins, Theranos, which was a company which claimed to have developed a device for testing blood that did it using a very small quantity of blood and diagnosed and administered treatments all on a wearable device, which turned out to be non-existent. And currently the founder is in court on charges of wire fraud to the tune of $9 billion. Mm-hmm. And I was questioning how one could, as an investor with 20 million or 30 million or however much money, large quantities of money, could invest in such a company when even a, cursory investigation of the core technology by somebody with a scientific background would have revealed that it's very unlikely that what they were proposing was possible. And he said to me that, well, ultimately, a lot of these VC firms and these investors, they see it as, or investing in startups as an exercise in gambling, essentially, where, you have an inkling, an intuition about perhaps how these things might go, but ultimately it's a high risk investment and you're prepared to let that money go. And what I think that, and it was interesting to me because, that's, if I had $20 million, that's definitely not the way I'd be investing. But it meant that it painted this picture of tech investment where it's essentially an exercise in speculation gambling and not an exercise in, studied investment. And I think it creates an environment in which products like the one we've been discussing today flourish, because all you have to do is create something, or you don't even need to create something. You can say you've created something. I'm not saying that that's the case in this case, but it's possible that you can just claim to have created something, and if you dress it up in the correct language and you convince the right people that you are telling the truth, and that such that they will vouch for you, then there's no reason why you can't attract huge amounts of funding. And I mean, the question, you can argue that this is a bad thing for science, and this is a bad thing for humanity because we're not making the best use of resources. But in my mind, it seems like something which could be avoided just by basic due diligence, which just doesn't seem to be done.
I think there's a couple of things there. I mean, one thing is that you say, if you had $20 million, that's not how you would invest it. I think one of the points is that these people don't have $20 million. They have far more than that. And $20 million is pocket change to a lot of these people, which is why they're willing to risk it. And also, you said that this kind of speculative gambling creates an environment in which this kind of product can flourish, but it's also this kind of person. And I'm not saying, like you pointed out, I'm not saying that AuReus is Theranos. It's not. There's nowhere near as much money on the line, and AuReus has something. There is a product there of some kind. don't know exactly what it is or whether it really works, but there's something there. But the key thing about Elizabeth Holmes and Theranos is that what made it work was her. She sold this story to all these people about the young, disruptive, genius inventor that so many people wanted to believe in. And that's the thing that is always in common with these kinds of inventions. It's even in common in this one. Now, the guy here, let me find his name. Kavi Eren Megu, I think Megu or Megwe. Anyway, this guy isn't an Elizabeth Holmes type character, but still, the invention is not just being sold on, here's something I've come up with that, could have this really important effect on the energy market. It's also, he's selling himself. He's saying, I am a young innovator. I am disruptive. I fulfill this image of this, young genius that people desperately want to believe in. And yeah, you're right. If you can convince somebody that you fit this archetype, then you can get this huge investment. And I suppose one of the things I think about your description of that process of capital investment is it is bad, it's a lot of money, and it's being wasted on things that don't work, and these people should be exercising proper due diligence. But ultimately, if they risked their money and they lost it, and the company that they invested in failed, it would be annoying and it would be bad for a lot of people because that money could have done a lot of good elsewhere. But ultimately, that is at least capitalism working as it's supposed to work, even if we might disagree as to whether that's a good thing.
Yes.
But the thing is that it often doesn't work that way, because what often seems to happen is the money gets invested, and rather than use that money to set up their business and manufacture their product and sell it and make it profitable, these, tech innovators, they take that money and they use it to further that marketing campaign, to present their product at Davos, to, fly to here and there to give demonstrations, to buy expensive marketing firms to sell them and their ideas. And then that increase in their image attracts more funding that they then use to continue to sell that image that attracts more funding. And it's almost like a pyramid scheme. I'm not saying this is a pyramid scheme. It's pyramid shaped, but it's not a pyramid scheme. But it is almost like that, where the investment only exists to sell the dream of this disruptive tech innovation to more investors who will continue to invest and keep the party going. And many of these companies never produce a marketable product.
Yes, and I think this calls back to a statement I made earlier, which is that this business model is taken from the tech industry, where it's well established that one of the best ways to make money in tech is to come up with an idea, create a startup, generate some interest, and then essentially operate at a loss, where you're constantly spending money to expand without actually generating any profit, until eventually either you can sell the company to somewhere like one of the big tech giants, or it all falls over. And that works in a tech environment because you have these, companies who are prepared to pay, huge amounts of money. So from a business perspective, it works. But that just doesn't work in the case where you have, no actual viable product and you're not in the tech sector.
Yeah. But sometimes it doesn't even work in the tech sector. I mean, what you said there about running at a loss until you can sell to a big tech company. I remember reading about someone who did this recently, who was, sell it, that their whole career now, I won't name them because I probably, if anyone was listening to this, I might get myself into trouble. But this person, they had been working in the tech sector, specifically on machine learning, and they'd started dozens of companies with very vague products related to machine learning. And none of those companies had run at a profit. Several of them had gone bankrupt and shut down. But eventually what they did was they hit on a product which wasn't still wasn't marketable. They still weren't making a profit on the product itself, but they managed to market the company for long enough and make it look exciting enough that an equity firm that was investing in, like a venture capital firm rather, that was investing in tech startups bought it for $20 million, and then they just bailed. And now their entire career is to go around and, be a entrepreneurial coach. And that is just such a common story. And it's common enough that you have to think at some point all of this dumped money, all this wasted capital has to come back to haunt people eventually. Like, you can't keep this party going forever.
Potentially. I mean, as long as a sufficient number of people are making a sufficient amount of money, I think the party will continue to go on.
You think, even if people are just acquiring, a tech company that has no marketable product and where its invention is fundamentally physically flawed, surely that's the definition of a toxic asset, isn't it? And if you've got people who are just buying up toxic assets ad nauseum. Well,
but the key thing is that as long as enough of those assets, of the subset of assets that you buy, are profitable,
I see,
then it offsets any losses that you have, and that's the nature of high risk investment. It's a gambling strategy, and some people who are operating on that strategy lose and eventually fall out of the game. But it's the gambler's fallacy. It's the enough people who go into it believe that they're going to be the ones to make the right picks, and then the people who do make the right picks are very visible in that they become very wealthy and very powerful.
So the tiny subset of tech companies that actually produce something saleable are just subsidizing
completely
all of this nonsense. Yeah, that's a pretty good summary of the situation, I think.
Yeah.
So I guess the sign off is tech investors, learn something about the fields you're investing in, for God's sake. And if you can't be bothered to learn about it, then at least talk to someone who can.
Yes, I think that's a fair summary.
James and I are free. We're happy to take checks for whatever. No, not really. I'm not allowed to do that. I'll get fired.
Yeah, probably unwise.